So if you're looking at this video, more than likely you're either going to be taking a class in linear circuits with me, you're thinking about taking a class in linear circuits with me, or you're looking at a lot of the online material and content and thinking this might be really interesting, and so kind of curious about how would such a course can come together. So we're going to talk through what is a course in linear circuits at a sort of an abstract level, and also a little of my own introduction so you get a sense of where I'm coming from this. So I'm Jennifer Hassler, and I absolutely love being able to teach circuits at all levels, particularly when we get to sort of the first classes in circuits. And one of the most important things when you're looking at this is kind of where would the course website be? And I've listed the course, at least the course website where it tends to live there for this. And realize that for me, there's a huge priority for having open materials, having open content wherever possible. So, strong believer on making all of this widely available. Also a strong believer that almost anybody can, anybody with the right sort of prerequisite material to this can do well. And one of the things that'll be important with all this is that there'll be a number of sort of short lecture nuggets. These are all sitting on YouTube. And one of the points is they're going to be short nuggets because this is what typically people's attention can handle very easily. You can watch it again, you can look at it again. It allows a lot of different opportunities throughout all of these approaches. So we'll try to have as much material open, things that I've done in the past, all sorts of course material. And so this is kind of how I will put these things together. Now, I am going to, in terms of evaluation for the way I teach these courses, it's almost always a mixture of objective and subjective material. And I usually consider the exams as being the objective part. There's just material that kind of just needs to be known. And that, after having worked with it and understanding it, you have some depth of knowledge and ability to use it. And then there's a subjective part. And those are going to be typically done as in terms of actual physical laboratory experiments. You can see below me what would be sort of a typical experiment. The beautiful thing is a lot of these can be done at home in a very straightforward way. You can do them in a coffee shop, you can do them in all sorts of places. And it's just one of the really neat things about doing electronics. There's so many different opportunities there. I do tend to believe strongly about doing labs in groups of 2, typically, partly because the conversations between people help, and trying to get that depth of knowledge is extremely important. And sometimes the depth of knowledge only comes by actually struggling with the material with someone else. And so this is really important. So there's other couple key rules that I would say, in terms of anyone taking a class with me. 1, please read the syllabus. Okay, please understand that I have a lot of material there. I've written it myself. I really try to make sure that it relates to what I'm doing in a particular time when I'm offering the class. So a second thing that's important is that when I usually form groups, I really feel like it's important to have them sort of self-organize. It doesn't make a lot of sense for me to try to over micromanage it when I start. Now, as time goes on through a course, I certainly reserve the right to move things around, and I may do that. Depends for all sorts of factors in a class, but we'll start with it being self-organized and we'll see where it goes. The other thing is that all of my classes are highly discussion-based and highly interactive. And I really want there to be a community where we're all kind of working together and interacting together. But what that also means is that there's several people who are not going to be comfortable and not going to lean into a conversation if they're sort of feeling like everything is being recorded, and particularly if other people are doing all of this. So I'm going to be very careful in general about what I'm recording, what I'm taking pictures of, and so forth in the class. And further, no one else in the class can record or take pictures. That way we can allow for an open conversation by everyone. And so I tend to be very have a very strong opinion about this because I really want to defend everyone in the class and the entire experience. Now, a couple of things that people will want to know, like sort of what was my own history of things. And so just a few points of that, and also a couple of things I actually look at in terms of research. Circuits is like very central to most of everything I do in terms of research, so it's always exciting to teach a first class in linear circuits. So a few things. I grew up in Florida, Arizona, spent time in California. When I moved to Georgia, it was the coldest place I had lived. And so, it kind of gives you a sense of my background. I did my undergrad and my master's degree at Arizona State, finished that in 1991. Did my PhD at Caltech in 1997. Got to work with Carver Mead, which was one of the most amazing experiences and one of the most amazing situations to be involved in for 5 years. It was an amazing time. And then in 1997, I started at Georgia Tech. Been a wonderful place to teach circuits. I've been involved in multiple startups, including companies like Gtronics, which was acquired by TI in 2010. There's a lot of wonderful stories in terms of how do you start taking academic research and moving it commercially. And then one other part, which is sort of my fourth degree, which is I have a Master's of Divinity from Emory that I got from Emory University, Candler School of Theology in 2020. So it gives me a sort of a different perspective as well of the interactions and the community we need to create in the classroom. My research interests have gone through many different places, but there's certain key things that have always been part of it. One has been an interest in neuroscience and learning the brain and that involves what we would now think of machine learning, and sometimes people call it AI. That's a longer story. A lot of interest in programmable and configurable analog and mixed signal electronics. This tends to be a very surprising thing when people think about, like, wait, I have digital as one thing and analog. Digital is programmable, analog is something that's fixed function. Very different, but it's a really fun and exciting area and something I've been very enthusiastic about for a while. This has also gotten me into various applications in always-on computing, context-aware computing, wearable computing, because of all of the energy and power constraints on this and the opportunities and what you can build. And then also just looking at the fact of these have to interface to real sensors. We have to build real tools around it. There's some just amazing opportunities. And so after all this, I just want to welcome all of you to this community, and I look forward to our further interactions.